Galileo Galilei, the father of modern science who dared to challenge the universe. Part 1. Early Life and Formation. Born on February 15, 1564, in Pisa, Italy, Galileo Galilei emerged into a world on the cusp of the scientific revolution. His father, Vincenzo Galilei, was an accomplished musician and music theorist whose questioning of established musical doctrines would later influence his son's scientific methodology. Born into a noble but financially struggling family, young Galileo's early environment was rich in intellectual discourse despite material limitations. His early education took place at the Camaldolese monastery in Vallombrosa, where he initially considered joining the monastic order. The structured religious education he received there would later play a complex role in his relationship with the Catholic Church. During these formative years, Galileo displayed an exceptional aptitude for mathematics and mechanical devices, often spending hours observing and sketching the monastery's mechanical clocks and other instruments. In 1581, following his father's wishes, Galileo enrolled at the University of Pisa to study medicine. However, his true passion emerged during a chance observation of a swinging chandelier in the Pisa Cathedral. This famous moment sparked his interest in the mathematics of pendulum motion, leading him to abandon medicine in favor of mathematics and natural philosophy. The young Galileo's intellectual development was profoundly influenced by the Renaissance atmosphere of questioning traditional authorities. He immersed himself in the works of Aristotle, not merely accepting them as divine truth as was common practice, but critically analyzing them through the lens of mathematical reasoning and experimental observation. This approach would become his trademark methodology throughout his scientific career. During these early years, Galileo developed the key characteristics that would define his later work: an unwavering commitment to mathematical precision, a healthy skepticism of established authorities, and an innovative approach to experimental design. His formation was marked by a unique combination of traditional education and independent thinking, setting the stage for his revolutionary contributions to science. Part 2. Early Career and Development. In 1589, at the age of 25, Galileo secured his first academic position as a mathematics professor at the University of Pisa. Despite his junior status, he quickly gained attention for challenging Aristotelian physics. His famous, though possibly apocryphal, demonstration at the Leaning Tower of Pisa, where he allegedly dropped objects of different weights to disprove Aristotle's theories about falling bodies, exemplified his emerging experimental approach. During this period, Galileo forged crucial relationships with influential patrons and fellow scholars. His friendship with Guidobaldo del Monte, a wealthy mathematician, proved particularly valuable. Del Monte's support helped Galileo secure a more prestigious position at the University of Padua in 1592, where he would spend the next 18 years, his most productive period of scientific work. At Padua, Galileo's ambitions expanded beyond pure mathematics into practical applications. He established a workshop producing mathematical instruments, including the geometric and military compass he invented. This enterprise not only supplemented his modest academic salary but also connected him with military and maritime practitioners who valued his instruments and expertise. A pivotal development came through his relationship with the Venetian arsenal, where he studied mechanics and military engineering. This practical experience influenced his theoretical work on motion and materials, leading to groundbreaking insights into the strength of materials and the behavior of projectiles. The turn of the century marked a significant transition in Galileo's career. His growing reputation attracted numerous students, including several future nobles and leaders. Among his private students was Cosimo de' Medici, who would later become Grand Duke of Tuscany and one of Galileo's most important patrons. During these years, Galileo began living with Marina Gamba, with whom he had 3 children. Though they never married, likely due to social class differences, this personal relationship added both domestic stability and financial responsibilities to his life. His eldest daughter, Virginia, later Sister Maria Celeste, would become one of his most devoted supporters during his later troubles with the Church. The Paduan period also saw Galileo's first serious astronomical observations. Reports of the Dutch telescope in 1608 prompted him to develop his own improved version. His technical skills, combined with his mathematical knowledge, allowed him to create instruments superior to those available elsewhere in Europe. This achievement would soon lead to his most famous discoveries and, ultimately, to both his greatest triumphs and most serious challenges. Part 3. Major Achievement Period I, 1609 to 1616. The year 1609 marked the beginning of Galileo's most revolutionary period of discovery. Using his improved telescope, he made a series of astronomical observations that would fundamentally change humanity's understanding of the cosmos. In December 1609, he began systematic observations of the Moon, discovering that its surface was not smooth and perfect as Aristotelian cosmology claimed, but rather mountainous and cratered. January 1610 brought his most stunning discovery: 4 moons orbiting Jupiter. He published these findings in Sidereus Nuncius, the Starry Messenger, which created an immediate sensation across Europe. The dedication of these discoveries to Cosimo de' Medici, calling the moons the Medicean stars, helped secure his appointment as chief mathematician and philosopher to the Grand Duke of Tuscany. This period saw Galileo overcome significant technical and observational challenges. He continually improved his telescopes, developing techniques for grinding and polishing lenses that produced unprecedented clarity. His observational skills were matched by his ability to interpret what he saw, recognizing, for example, that the changing phases of Venus could only be explained by the planet orbiting the Sun rather than Earth. These astronomical discoveries provided crucial evidence supporting the Copernican heliocentric theory. However, this created increasing tension with religious authorities. In 1611, Galileo traveled to Rome to demonstrate his telescope to the Jesuit astronomers of the Roman College, gaining their crucial initial support. However, conservative elements within the Church began to view his work with growing suspicion. Part 4. Major Achievement Period II, 1616 to 1633. The years following 1616 marked a complex period in Galileo's scientific career. Despite receiving a warning from Cardinal Bellarmine to treat heliocentrism only as a mathematical hypothesis, Galileo continued his research while carefully navigating ecclesiastical politics. In 1623, his friend and supporter Cardinal Barberini became Pope Urban VIII, seemingly opening a window of opportunity. During this period, Galileo made significant contributions beyond astronomy. His work, The Assayer, 1623, laid out his scientific methodology, arguing that the book of nature was written in mathematical language. He conducted groundbreaking studies in physics, including his analysis of projectile motion and the principles of relativity in motion. The culmination of this period was the publication of his masterwork, Dialogue Concerning the Two Chief World Systems, 1632. Written in Italian rather than Latin, it presented arguments for and against the Copernican system through a dialogue between 3 characters. Despite careful framing and official permission to publish, the book ultimately led to his trial by the Inquisition. The challenges faced during this period were immense. Galileo had to balance scientific truth with theological orthodoxy, personal safety with intellectual integrity. His solution was to attempt to separate scientific and religious truth, arguing that Scripture taught how to go to heaven, not how the heavens go. However, this approach ultimately failed to protect him from ecclesiastical censure. Part 5. Impact and Influence. The immediate effects of Galileo's work were profound and far-reaching. His telescopic discoveries revolutionized astronomy, while his experimental method transformed the practice of science itself. The concept of mathematical physics, describing natural phenomena through mathematical relationships, became a cornerstone of modern science. Long-term consequences included the gradual acceptance of the scientific method as the primary means of investigating natural phenomena. Galileo's work laid the groundwork for Newton's laws of motion and universal gravitation. His emphasis on experimental verification and mathematical description of nature became fundamental principles of modern science. The global impact extended beyond science. The Galileo affair became a symbol of the conflict between scientific inquiry and religious authority, influencing debates about the relationship between science and religion that continue to this day. His work contributed to the broader intellectual movement that would become the Enlightenment. Historically, Galileo's influence can be seen in the development of modern scientific institutions and practices. His insistence on empirical evidence and mathematical precision set standards that remain central to scientific investigation. The controversy surrounding his trial highlighted the importance of intellectual freedom and the separation of scientific and religious authority. Part 6. Legacy and Modern Relevance. Historical assessment of Galileo has evolved significantly. While initially condemned by the Church, he was gradually rehabilitated, with Pope John Paul II formally expressing regret for his treatment in 1992. Historians now recognize him as a pivotal figure in the scientific revolution, combining mathematical theory with experimental verification. Contemporary significance extends across multiple domains. His advocacy for scientific freedom and rational inquiry remains relevant in current debates about science policy and education. The scientific method he helped establish continues to drive technological progress and scientific discovery. The ongoing influence of Galileo's work can be seen in modern physics, astronomy, and scientific methodology. His approach to problem-solving, breaking complex issues into manageable parts and applying mathematical analysis, remains fundamental to scientific research. Modern perspectives increasingly appreciate Galileo's role as a public intellectual and communicator of science. His choice to write in Italian rather than Latin, and his use of dialogue to explain complex ideas, prefigured modern efforts to make science accessible to the general public. Galileo Galilei stands as one of the most influential figures in the history of science. His combination of theoretical insight, experimental ingenuity, and mathematical precision transformed our understanding of the natural world and established the foundations of modern scientific methodology. Beyond his specific discoveries, his courage in defending scientific truth against institutional opposition set an enduring example of intellectual integrity. The relevance of Galileo's story continues to grow in our era of rapid technological change and competing claims to truth. His insistence on empirical evidence and mathematical precision, his skill in communicating complex ideas to the public, and his navigation of the relationship between science and society provide valuable lessons for contemporary challenges. For modern audiences, Galileo's legacy invites us to question established beliefs when evidence demands it, seek mathematical and empirical foundations for our understanding of nature, balance the pursuit of truth with social responsibility, communicate scientific ideas clearly and effectively to the public.